Imagine if you could travel back in time to the very moment when nothing we know existed. No stars, no planets, not even space or time, just absolute nothingness. And then, out of this void, an unimaginable explosion occurs, giving birth to everything. This is the Big Bang Theory. The moment the universe began, it's one of the most extraordinary concepts in science, challenging us to grasp how something could emerge from nothing. Today, we're going to dive deep into this fascinating theory, exploring how the universe came to be from its explosive beginning to the stars and galaxies that light up our skies. By the end of this video, you'll see the universe in a completely new light, understanding its origins in a way that will leave you speechless. Have you ever stopped to think that everything we see, feel, and touch was once the result of a single cosmic explosion billions of years ago? How could one explosion be responsible for the formation of galaxies, stars, and even life here on Earth? And the bigger question, is the universe still expanding today? These are some of the mysteries we'll unravel in this video. The answers might be more mind-blowing than you expect. Stick around as we uncover how the Big Bang shaped every corner of the cosmos and what that means for the future of the universe. If you're as curious as I am about the universe's incredible journey from nothingness to everything, don't forget to hit the like button and subscribe to our channel, Exploring the Universe, for more cosmic adventures. The Big Bang is one of the most important scientific theories in cosmology, explaining how our universe originated. According to this theory, around 13,800,000,000 years ago, all the matter, energy, and even the fabric of space and time were compressed into a single point, known as a singularity. This point was not only incredibly small, infinitely small in fact, but also unimaginably hot and dense. In an instant, this singularity began expanding at an extraordinary rate. This rapid expansion is what we refer to as the Big Bang, and it marked the very beginning of our universe. Now, it's important to clarify something. When we hear Big Bang, we might imagine a massive explosion like a bomb going off in space, but that's not quite accurate. The Big Bang wasn't an explosion in a specific location within space. It was the expansion of space itself. Before the Big Bang, space as we know it didn't exist. So, rather than something blowing up into pre-existing space, the Big Bang created space and time as it expanded. It's a mind-bending concept, but imagine it like this. The universe wasn't expanding into anything. It was space itself that was growing. As space expanded, it carried matter along with it, cooling down over time. During this early stage, particles like quarks and electrons began to form. Eventually, these particles combined to create atoms, which later formed clouds of gas. Over billions of years, these gas clouds coalesced into the first stars and galaxies. Everything we see today, from the smallest particles to the largest galaxies, began as a result of this cosmic expansion. Another important aspect to understand is that the Big Bang didn't just mark the beginning of space, but also the beginning of time. Before the Big Bang, there was no before in the way we understand time. Time itself began with the universe's birth. This idea fundamentally changes how we think about the origin of the cosmos, as it suggests that the universe has no edge, no center, and no time before the Big Bang. In addition to this, the Big Bang theory is supported by a number of key observations. For example, scientists have discovered the cosmic microwave background, which is essentially the afterglow of the Big Bang, faint radiation that fills the universe and provides a snapshot of what it looked like shortly after its birth. This discovery, made in the 1960s, provided strong evidence that the universe started from a hot, dense state. Another crucial piece of evidence is the fact that the universe is still expanding today. Observations of distant galaxies show that they are moving away from us, which implies that the universe is growing larger all the time. This ongoing expansion is a direct consequence of the initial burst of energy from the Big Bang, and it suggests that the universe could continue to expand indefinitely. In summary, the Big Bang was not just a moment of creation, but the beginning of everything: space, time, matter, and energy. It set into motion the processes that would eventually lead to the formation of galaxies, stars, planets, and life itself. And although we've made incredible progress in understanding this event, the Big Bang still raises deep questions about the ultimate fate of the universe, the nature of time, and the mysteries that lie beyond our current knowledge. The Big Bang Theory might sound like a mind-boggling idea, but it's backed by solid scientific evidence. So, how do scientists know that the Big Bang really happened? One of the most convincing pieces of evidence is something called the cosmic microwave background radiation. This radiation is essentially a faint glow that fills the entire universe, a remnant of the intense heat from the early moments after the Big Bang. Discovered in 1965 by Arno Penzias and Robert Wilson, the CMB provides a snapshot of what the universe looked like when it was just 380,000 years old, a time when it was much hotter and denser than it is today. The CMB is often described as the echo of the Big Bang, because it's like the afterglow of that colossal event. It's composed of microwaves, a type of light that is invisible to the naked eye, and it has been cooling down as the universe expands. Originally, this radiation was incredibly hot, but over billions of years, as space stretched out, the energy has dissipated, leaving behind this faint, cold glow. The CMB's existence is a critical piece of evidence because it fits exactly with what we would expect if the universe began in a hot, dense state and has been expanding ever since. Another key piece of evidence supporting the Big Bang is the fact that the universe is still expanding. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. Distant galaxies are moving away from us, and the farther away they are, the faster they're receding. This observation, known as Hubble's law, provided the first direct evidence that the universe is expanding. Think of it like dots on a balloon. As the balloon inflates, the dots move farther apart. In the same way, space itself is expanding, and everything within it, galaxies, stars, and planets, is moving away from everything else. But there's more. The concept of redshift is another key observation that supports the Big Bang. When astronomers look at the light coming from distant galaxies, they notice that it's shifted toward the red end of the spectrum. This shift happens because the galaxies are moving away from us, and as they do, the wavelength of the light stretches, becoming longer and redder. This redshift is a direct consequence of the universe's expansion, and it provides concrete evidence that space itself is stretching out over time. Together, the CMB and the expanding universe form a compelling case for the Big Bang, but scientists have also gathered other evidence, such as the abundance of light elements like hydrogen and helium. According to the Big Bang Theory, the universe was so hot in its early moments that nuclear reactions took place, fusing protons and neutrons into the first elements. The theory predicts that the universe should be made up of about 75% hydrogen and 25% helium by mass, which is precisely what we observe today. In essence, the scientific community relies on these observations, the CMB, the redshift of galaxies, and the composition of elements, to confirm that the Big Bang is not just a theory, but the most accurate explanation we have for the origin of the universe. Every piece of evidence we've uncovered so far fits perfectly into this puzzle, painting a picture of a universe that began from a tiny, hot, and dense point, and has been expanding and evolving ever since. So, when you look up at the night sky and see the stars, remember that they are not just twinkling points of light. They are part of a universe that is constantly expanding, a universe born from a singular moment of creation, the Big Bang. Every galaxy, every star, every planet is a part of this grand cosmic story, a story that scientists continue to unravel with every new discovery. The first few minutes after the Big Bang were some of the most critical moments in the history of the universe. Imagine a cauldron of unimaginable heat and energy, where temperatures reach trillions of degrees Celsius. In these extreme conditions, the universe was a chaotic soup of subatomic particles like quarks, gluons, electrons, and neutrinos, moving at nearly the speed of light. This primordial state is known as the quark-gluon plasma, a super hot, super dense mixture that would later give rise to all matter in the universe. In the first fractions of a second, as the universe expanded and began to cool, these quarks began to bind together to form protons and neutrons, the building blocks of atomic nuclei. This process, known as baryogenesis, occurred in the blink of an eye. The cooling was essential because at such high temperatures, no stable matter could exist. As the universe cooled to more manageable temperatures, still billions of degrees, these particles could finally interact and combine in meaningful ways. Around 3 minutes after the Big Bang, something incredible happened. The universe had cooled enough for protons and neutrons to start fusing together, forming the nuclei of the first atoms. This process is called nucleosynthesis, and it's responsible for creating the lightest and most abundant elements in the universe, hydrogen and helium. In fact, about 75% of the normal matter in the universe became hydrogen and 25% became helium, trace amounts of other light elements like lithium and deuterium were also formed during this time. These first few minutes were absolutely pivotal because they set the stage for everything that came after. The hydrogen and helium produced during nucleosynthesis would later become the raw material for the first stars, galaxies, and even planets. Without this early production of elements, there would be no stars to light up the night sky and no heavy elements to form the rocky planets like Earth. It's also worth noting that the first few minutes after the Big Bang were a time of incredible energy. As particles collided and fused, they released vast amounts of energy in the form of radiation. This radiation, initially in the form of high-energy gamma rays, would eventually cool down as the universe expanded and is still observable today as the cosmic microwave background, the faint afterglow of the Big Bang that fills the universe. But perhaps one of the most fascinating aspects of this early universe is that within the first 3 minutes, the universe's fate was already sealed. The proportions of hydrogen and helium formed during nucleosynthesis determined much of what the universe would become. For example, the ratio of these elements affected how stars would form, how galaxies would evolve, and even the future chemistry of planets and life itself. It's incredible to think that, within such a short period, the universe's blueprint was already being drawn. After these first 3 minutes, the universe continued to expand and cool. By the time it was about 380,000 years old, it had cooled enough for the first atoms to form, allowing light to finally travel freely through space. This was the moment when the universe became transparent, and it's the moment we see when we look at the cosmic microwave background. The first minutes after the Big Bang were a period of intense activity and rapid change. From a chaotic sea of subatomic particles to the formation of the first atomic nuclei, these moments shaped the structure and evolution of the universe we observe today. The next time you look up at the stars, remember that their very existence was made possible by the events that unfolded in those crucial first minutes of cosmic history. If you're as fascinated as I am by this incredible journey through the origins of the universe, don't forget to give this video a thumbs up and hit that subscribe button. We're just getting started, and there's so much more to explore together here on Exploring the Universe. From distant galaxies to the mysteries of black holes, we're on a never-ending adventure through the cosmos. Stick around, and who knows what new wonders we'll uncover next. Gravity is often called the architect of the universe because after the Big Bang, it became the driving force behind the formation of everything we see today. Once the first atoms of hydrogen and helium formed, gravity started to take over. Even though these atoms were spread out, gravity began to pull them together, causing clouds of gas to form. Over millions of years, these gas clouds collapsed under their own gravitational pull, becoming denser and hotter, eventually igniting the nuclear fusion that would create the first stars. Without gravity, these gas clouds would have drifted aimlessly through space, never coalescing into the structures we now observe. Gravity didn't just form stars, though. It also brought stars together to create galaxies, and it continues to shape the universe today. Galaxies, star clusters, planets, all of them owe their existence to the gravitational force that holds everything together. As gravity pulled gas clouds into denser regions, it also created the conditions necessary for the formation of planets and moons. After stars formed, leftover material orbiting them clumped together, eventually forming planets like Earth. This process, called accretion, wouldn't be possible without gravity continually pulling material inward. So from the largest galaxy to the smallest moon, gravity is responsible for creating the complex structures we see in the universe. What's even more fascinating is that gravity's influence is not limited to the matter we can see. Scientists now know that much of the universe is made up of dark matter, an invisible substance that doesn't interact with light but has mass and, therefore, exerts gravitational force. Dark matter plays a crucial role in shaping galaxies and even influences the expansion of the universe. In short, gravity is the cosmic sculptor that transformed the chaotic aftermath of the Big Bang into the universe we know today. From the formation of stars and planets to the structure of entire galaxies, gravity has shaped every aspect of the cosmos. Without it, the universe would be a vastly different place, one without the intricate systems that allow life like ours to exist. Today, we know that the universe is still expanding, but this raises a profound and intriguing question. How long will this expansion continue? What is the ultimate fate of the cosmos? Scientists have developed several theories to explain what might happen in the distant future. And while we can't be certain, each theory offers a fascinating glimpse into the possible end of the universe. One of the most widely accepted theories is known as the Big Freeze or heat death. Chirobui son origin staris. This theory suggests that the universe will continue expanding forever, but as it does, galaxies, stars, and even planets will drift further apart. Over billions of years, the distances between these celestial bodies will become so vast that galaxies will no longer interact with each other. Stars will eventually burn out, and new stars won't be able to form because the raw materials for star formation will be too spread out. As the universe cools, it will become a dark, cold, and empty place, with only remnants of dead stars and black holes scattered throughout. This big freeze predicts a universe where all energy has been used up and nothing remains but a cold void. But there's another theory called the Big Crunch, which takes a completely different approach. This theory proposes that at some point, the expansion of the universe might slow down and reverse. Instead of expanding forever, gravity could eventually overcome the outward push of the expansion, pulling everything back toward a central point. In this scenario, the universe would begin to contract, with galaxies, stars, and planets being drawn back together. Eventually, everything would collapse into a singularity, essentially the reverse of the Big Bang. This Big Crunch would mark the end of the universe as we know it, potentially leading to a new cycle of cosmic birth and death. A more recent and compelling theory is the Big Rip. This hypothesis is based on the idea that dark energy, the mysterious force that is driving the accelerated expansion of the universe, could become stronger over time. If dark energy continues to grow, it could eventually reach a point where it tears apart galaxies, stars, planets, and even the atoms themselves. In the final moments of the universe, all matter could be ripped apart, leaving nothing but an endless, chaotic expanse. The Big Rip is one of the more dramatic and catastrophic predictions for the universe's future. And then there's the possibility that we live in a universe that might experience cosmic rebirth. According to some models, after a big crunch or a similar collapse, the universe could go through another Big Bang, creating a new universe with different properties. This cyclical model suggests that the universe may undergo infinite cycles of birth, death, and rebirth, where each universe is followed by another forever. What's remarkable is that we're still gathering data to understand which, if any, of these theories might be correct. The discovery of dark energy, the force driving the accelerated expansion of the universe, has complicated our understanding of cosmic fate. Scientists are continually observing the universe, looking for clues that might point us toward one theory or another. One thing is certain: the future of the universe is just as mysterious and awe-inspiring as its origin. In the end, while we may never witness the final moments of the universe, we can continue to explore and study the cosmos, seeking to understand not just where we come from, but also where we are headed. The fate of the universe remains one of the greatest unsolved mysteries in science. And with each discovery, we get one step closer to unlocking the ultimate destiny of everything we know. As we reflect on the Big Bang, we're reminded that our very existence is tied to an event far grander than we can fully comprehend, an event that has been unfolding for billions of years. The atoms that make up our bodies, the air we breathe, and the stars we gaze upon all originated from that single moment of creation. We are quite literally made of stardust, the remnants of stars that exploded long ago, scattering the elements necessary for life across the cosmos. The Big Bang was not just the birth of the universe, but the birth of everything we know. With the knowledge we've gained, it's clear that the universe is still revealing its secrets. Every discovery we make about distant galaxies, black holes, or the nature of dark energy brings us closer to understanding the grand tapestry of existence. But the more we learn, the more questions arise. What mysteries still lie hidden in the depths of space? What new phenomena will we uncover as our tools and technologies evolve? These are the questions that drive our exploration, fueling our curiosity and sense of wonder. As we continue to unravel the cosmos, we are not just observers, but participants in a vast and dynamic universe. Each discovery, no matter how small, helps us piece together the story of the universe's past, present, and future. And who knows? The next groundbreaking revelation might come from a question you've asked, or a discovery yet to be made. The universe is infinite in its wonders, and our journey through it has only just begun. So keep exploring with us. The next great discovery might be just around the corner, waiting to challenge everything we think we know. Together, we'll continue to journey through the stars, one mystery at a time. If you've been as captivated by the incredible story of the Big Bang as I have, then this is just the beginning of our cosmic adventure. There's so much more to explore, from the mysteries of black holes to the search for extraterrestrial life and the most distant galaxies in the universe. If you're curious to learn more about how the cosmos works and want to dive deeper into the most fascinating aspects of astronomy, make sure to subscribe to Exploring the Universe. By subscribing, you'll never miss out on the latest videos that will keep you informed and inspired about the wonders of space. And don't forget to hit the notification bell so you'll be the first to know when we upload a new video. We're building a community of space enthusiasts just like you, and your support helps us keep pushing the boundaries of what we can discover together. So, let's continue this journey through the stars. Who knows what we'll find next? Thank you for watching, and I can't wait to see you in the next episode.